Number 11. A book distributor is trying to divide an order of textbooks into equally sized groups for shipping in cartons. The textbooks can be divided into groups of 12, groups of 15, or groups of 18, with no books left over. Which of the following inequalities is satisfied if n is the smallest possible number of textbooks? It gives us a bunch of inequalities. Well, let's see. I'm thinking of n. And n is going to be the smallest possible number of textbooks. And it tells me n can be divided by 15. N can be divided by 18. And n can be divided by 12. So, looking at this slightly differently, 12, 15, and 18. These are, n is a multiple. It's a multiple of 12, 15, and 18 because 12 has to be able to go into n evenly, and 15 goes into n evenly. So does 18. And 12, 15, and 18, they're factors of n. And I'm not just looking for any multiple of 12, 15, and 18, because if I were, all I would do is multiply the 12, the 15, and 18. I get some really big number, and that would be a multiple. That would be a big multiple. But I'm not. I'm looking for the smallest possible total number of textbooks. I'm looking for the smallest or lowest possible textbooks. So this right here, this catchphrase, the smallest possible, that's a hint that it's looking for the lowest common multiple. Or we're going to call this the LCM. So now that we know that we're looking for the lowest common multiple of 12, 15, and 18, we've got to solve for it. There's a bunch of different strategies to do that. There is the tried and true method of this strategy here. I could do 12, 15, 18, and I could start writing out the multiples. 12, 24, 36, 48. This is going to help me find the lowest common multiple. This is one way to do it. Well, here's 15, 30, 45, 60, 75. Oh, I got a pattern here. Now all I need to do is find one more. 18, 36, 54, 72. Oh, I got a pattern here, but not here. Well, the problem, this strategy definitely works for maybe two numbers if they're small, but it gets really tricky as I go along, and it takes a long time because they don't all share a multiple till way out here. We've got to find another way to do that. And there is a way, and I call it I'm gonna say this is the Venn diagram way to find the lowest common multiple. So I think that's how you spell Venn. This is a really good way. It works for two numbers, but it really works for three numbers. Because with three numbers, it helps to organize my information. And this is how it works. First, you write out your numbers, set up your Venn diagram for each one of the numbers. Then you do the prime factorization, 12. Prime factorization, you do a factor tree, pulling out the prime numbers now. You get to this step here, This is where it gets tricky and it takes some practice. So it's going to take some practice to get the hang of it. I'm going to put in my Venn diagram what's common in the center. So I see this has a 3, this has a 3, and this has a 3. Good. Let's see, anything else shared? Oh, by the way, this should be a 5. Pardon me. Anything else shared? Does the... I think this should be a 2. All these little mistakes. Well, mistakes happen, so take your time. And don't do this at 6 o'clock in the morning. Trust me. Let's see. So let me see if I got this one right. Yeah, and I got this one. Okay. So any other common areas? Well, the 12 and the 18, they both share a 2, so I could cross out the 2 here and the 2 here and put that here. And then it doesn't look like there's any other common area, so I'm just going to fill it in. Here's my 18. Here's my 12. Here's my 15. So these would be the factors of 12, the prime factors of 12. These are the prime factors of 15, and these are the prime factors of 18. Now to find the lowest common multiple, I'm going to multiply all the numbers that are remaining in my Venn diagram. So that would be 2 times 2 times 3 times 3 times 5. And the product of these numbers should be n. So let's see, we have 4 times 9 times 5. We have 36 times 5. We have 180. So n is equal to 180. The smallest, the lowest common multiple is equal to 180, which is very helpful because now when I go back to my problem and I look at my inequality, I ask myself, is 180, is it greater than or equal to 100? Yes. But is it less than 150? No. Is 180 greater than 150? Yes. But less than 200? Yes. Number B is my answer.